Welcome back, ladies and gentlemen. All right, so for our second graph that's related to trig that we are going to talk about, we are going to talk about cosine. And when we do this, we are also going to review our key steps for graphing really any trig function. We're going to do it with cosine, but really you can do it with any function. So we're going to get started here right away. And there's one major change I want to talk about in relation to graphing cosine in comparison to graphing sine, which you've already graphed. So the big thing to remember is that cosine deals with x values. So this may seem a little bit weird, but every time we graph something related to cosine, we're going to graph an angle and then the x value at that angle. Okay, and as we do this first parent function, I'm just going to draw us a little unit circle so that we can talk about these values as we work around the unit circle. Once again, I am going to draw my axis in the middle. And for this first one, my horizontal axis. And for this first one, I'm going to draw my vertical axis on the far left-hand side. So remember that anything on the horizontal axis is theta. And for this, since it's cosine, anything that's along the vertical axis is really going to be an x value. Okay, so let's start off at 0. And recognize that that ordered pair would be 1, 0. So what is the height of our graph starting at? It's starting at a height of 1. Okay, and then we're going to use the same key points. So we're going to use pi over 2, pi, 3 pi over 2, and 2 pi. All right, we're going to use the same scale for our graph, but if you notice, when we do finish this graph out, it will look slightly different. So when we get to pi over 2, this ordered pair is 0, 1. So our x value is now 0. So we're on our horizontal axis. And then when we come over here to pi at our far left, we're at negative 1, 0. So that gives us negative, oh, sorry about that, folks. That gives us negative 1 down here. And then when we come to 3 pi over 2, that's again 0, negative 1, but all we really care about is the x value, so we have 0. And then when we're back at 2 pi, we're up at 1. So notice, once again, we have a repeating pattern where we are like above and below the horizontal axis. It's just that cosine starts up here at the top, goes all the way down, and then comes all the way back up. And then if you wanted to repeat that for a second cycle, oh, sorry folks, laundry going on right now. Clearly my dryer is done. All right, we'll worry about that later. Okay, so at any rate, I just drew for you a second cycle. So then if we were to keep that going, we know that since it's a period of 2 pi, all right, if we look, we ended at 2 pi right here. We know that this spot here would be 4 pi. We'd have 3 pi right here. And so, you know, we'd have 5 pi over 2 right here and 7 pi over 2 after that. It's always important to fill out your entire horizontal axis just so you have a good sense of your scale. Okay, so that's the parent function. Key thing to really remember is that you're starting at 1 and working your way down and ending back at 1. That's one cycle, okay? Something similar to sine, looking at cosine, we have a couple of things that are identical. For example, the parent function domain is still going to be negative infinity to infinity. Again, I know that I've only graphed 2 cycles, 2 periods here, but this could keep going forever and ever and ever up and down periodically as it bounces up and down to the peaks and valleys of this graph. The range is also, very similarly written. And in this case, it's identical because the graph goes all the way down to negative 1 and then goes all the way up to 1. As I've already said, the period of your parent function is 2 pi and your amplitude is 1. So really the only thing that was different here is that we started at our peak at 1 and then went through our cycle. And so it kind of makes this like big valley, all right, as you're graphing it. To review our process for graphing any trig function, I just want to go over it might seem like a lot of steps, but you don't always have to do all 6 of these steps. And if you're the kind of person that likes an equation, I'm going to kind of reference some different locations in the sine or cosine equation to help you identify which number does what. So the key thing, and probably the most important thing, is to start out with anytime you have a horizontal shift, making sure that you take whatever's inside and you set the to be more specific, we're going to set your argument equal to 0 and solve, okay? And that's going to give you your horizontal shift, okay? To identify the period, you're always going to take 2 pi and divide it by the b value, okay? And so the b value is this number right inside in front of the x value, okay? And so I am going to make a little note that tangent is different. Okay, you'll see in a little bit. But just remember that for now, 2 pi divided by b will get you your period. And then when you go to scale your axis, you take the period and you divide that by 4. Okay, to scale the horizontal axis. And then shifting vertically, use D, that's this number outside, to shift the midline up or down, and that does exactly what you think it does. If it's positive, it goes up. If it's negative, it goes down. All right, draw the midline. Now, you may think that this isn't super important, but I would strongly encourage you to draw the midline at the value of D, okay? It's going to be a horizontal, and let's make it dotted, okay? That's to help you make sure you're equally distributing your graph above and below wherever the new middle of your graph is. It's easy right now to know where the middle is because the middle of this graph is just the horizontal axis. So it's very easy to see that it's above and below, okay? But when you shift that, when you start to mess around with that, it can be a little challenging. So then the last thing you need to worry about is applying the amplitude, which is very nice because that's the, remember to multiply by A for the amplitude. And just as a side note, if A is negative, that's going to cause a reflection, okay? Basically what that means, and I'll try and draw this real quickly. If you think about sine from yesterday, which goes up and comes down, it would go down and then come up. Okay, that's a reflection. And then cosine, which we're talking about today, which starts at 1, so it starts up here, goes all the way down to its valley and comes back up. If we're talking about it reflecting, it would start at -1, go up, kind of make a mountain and come back down. Okay, so you'll figure it out because, you know, 1 times a negative is just going to be a negative number or whatever it is. Anyway, all right, so moving along, let's take a look. And I'm actually going to skip our first example because I want to do one that has 2 things going on in it. Okay, so just a heads up, this is an argument. If we set 2x equal to 0, x equals 0, so we don't have any horizontal shift, which is nice. But we do have a vertical dilation right here. So I'm going to draw my horizontal axis up 1, just so that my graph still is in the middle. And then I'm going to draw my vertical axis right through the middle here. Okay, so this number right here represents my midline, okay? So -1. So -1 is my midline. Okay, so the first thing that I did was I checked to see if there was a horizontal shift. No horizontal shift. The next thing, my apologies for skipping this, is to check the period. So since b equals 2, we're going to take 2 pi, divide it by 2. You could write it like this. This is how I would normally write it. So your period would be pi. And if the period is pi, then when we take that number and divide it by 4, that is going to give us our scale for our axis. So we're starting at 0, then pi divided by 4, then 2 pi over 4 is really just pi over 2, 3 pi over 4s, and then 4 over 4 is just 1 pi over 4. Notice how that number matches our period. That means that's where my graph should end, okay? And so since we're graphing cosine, cosine's supposed to start 1 unit above the midline, so it's really going to start at 0. And I'm actually going to try and pick a much lighter color. 0, right there. Actually, I know, I just can't decide. So many colors. Okay, we're going to go with hot pink. So it's supposed to start there, then go down, come all the way down, 1 unit, come back up. Now, why didn't I mess with the amplitude? Because the number right here is 1. Okay, so I kind of get to skip that last step where it says multiply by the amplitude because there is no change. So now I've got 1 cycle of cosine. And somewhere I am confident that the directions say that you're supposed to draw 2 cycles. So we're just going to take our graph and we're basically going to reflect that backwards. Okay, and we're going to draw in all those points so that I get a second cycle of cosine. And like I already said, make sure you make your graph curvy, all right? These are not straight. These are nice curves that we're graphing. And if I go backwards, I'd have negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. That would be the complete scale for my horizontal axis. And then my domain, negative infinity to infinity, we should be sensing a theme. But my range definitely changes because now I'm down here at negative 2. And make sure if you haven't filled out your horizontal or your vertical axis that you do that, okay? Especially when you go back to double check your range. So negative 2 to 0 would be our range. My apologies, folks. I'm keeping you on your toes. We did number 3 and now we're going back to number 2. Okay, so I'm trying to go through each of these steps that I just talked about in their order. So remember, the first thing you want to do is take your argument and set it equal to 0. Okay, so in this case, that means we're going to get negative 3 pi over 4. Now, we haven't really addressed that yet. So I'm going to draw in a vertical axis, okay? And that number, you're going to put on your vertical axis, okay? Negative 3 pi. Let me just double check. Negative 3 pi over 4. Okay? And so I'm putting that on my axis because that's our shift. Okay? And that's what we're going to use as our starting point for our graph instead of normally what we would start with, which is 0. Okay? So then I'm going to check a couple other things. I'm going to check this number in front of x, which is 1. So that's our b value. So if I take, if b is 1, if I take 2 pi and I divide it by 1, which might seem a little unnecessary, we notice that our period is 2 pi. And so our scale is going to be 2 pi divided by 4, or pi over 2. So that's our scale. Okay, so this means you've got to do a little bit of math in your head, all right? So you actually might want to think about it as 2 pi over 4, because here's what you're going to do. You're going to take negative 3 over 4, and you're going to add 2/4 to that. So you're going to get negative 1 over 4. And then you're going to add another 2/4. So you're going to get positive pi over 4. And then you're going to add 2 to that, and so you're going to get 3 pi over 4. Okay, and you're going to do that until you get 4 of these. And so then 3 plus 2, that's 5 pi over 4. Okay, and why am I getting 4? Because I need a grand total of 5 tick marks to make my graph. Okay, so then to kind of quickly go through these last couple of things, this is going to be my shift, my vertical shift up. So instead of being at 1, I'm going to be at 2. That's my middle. All right, so I'm drawing in my midline. All right, and then from there, I don't have anything else going on because there's a 1 in front of there. So I'm going to make my cosine graph. So my cosine graph is really going to start at 3. So 1, 2, 3. It's going to go down 1 on my midline, come below my midline 1 unit, come back up, and then go all the way up. And now I've got 1 period of cosine and my second period of cosine just